So, how's the weather?
Hey guys, my name is David Leal, and today I'll be talking to you all about the eruption of Mount St. Helens 46 years ago, which has to do directly with what we studied in Chapter 14 on internal processes, like with volcanoes and earthquakes. I'll also talk about how that's connected to mass wasting, which we talked about in Chapter 15. So here we go. So here's an introduction to Mount St. Helens. The mountain is located in Skamania County in Washington State, which is not too far from Vancouver, Washington, and Portland, Oregon. And it's also a part of the Cascade Mountain Range. It's part of what our book calls the Pacific Ring of Fire, which is where many earthquakes and volcanic activity occur due to the movement of plate tectonics. It currently sits at 8,365 feet above sea level and is known as a stratovolcano. So a stratovolcano is a volcano that is made up of ash, lava, and rocks. So like when I think of a volcano, usually I think of the ones in Hawaii that have those smooth lava flows, maybe it's oozing down the mountain. It's that bright red color. Those are called shield volcanoes. Whereas with volcanoes like Mount St. Helens, the lava is a more hard, rocky consistency. What the lava actually turns into is a pumice stone. So you'll see people using pumice stones for pedicures and stuff. But yeah, pumice stones are rock that come from cooled lava. The lava cools almost instantly when making contact with the air. The eruptions are called Plinian eruptions and are way more violent and explosive. So you'll see hot gas and ash and pumice shooting out from the volcano. Mount St. Helens' last eruption was back in 2008, but even though it experienced activity in 2008, nothing compares to its eruption that took place in 1980. If you notice, this picture is showing how the mountain or volcano originally looked before the eruption. You see this nice cone-like shape. The 1980 eruption completely blew that portion of the mountain off. It's incredible to see how powerful this eruption really was. People have compared the old Mount St. Helens to Mount Fuji in Japan. But after its eruption, the difference in its appearance is night and day. May 18th, 1980. This eruption was a monumental moment in history. It was all over the news, probably for weeks, and multiple parts of the US were impacted by this. The volcano lay dormant for 123 years up until that point, which is why I referred to it as the sleeping giant. This picture is mind-boggling to me. I mean, look at that. To have been there to capture this would have been insane. Like, I'm picturing the person taking this photo at the time. So many emotions would have flooded my mind all at once. Like, wow, that's so cool. But, at the same time, it's overwhelming. This is very overwhelming. Here's a guy water skiing with the eruption in the background. Another guy you see just pitching in a baseball game. No big deal, Below that are some kids posing for a photo with the clouds. The kids in the picture on the right are writing May 20th, 1980 on the windshield of their car. So here's some pictures of the ash. I actually have an uncle who lived in Spokane, Washington at that time, and my uncle said it was like nighttime during the day. He said the falling ash looked like snow coming down. But yeah, the ash blew all over the country. I think these are the coolest shots ever. So those clouds you see are the ash and pumice mixed together. The mixture is called tephra. The blast lasted for 9 straight hours, and the tephra cloud reached 80,000 feet into the air. This is crazy. The motion of the blast is called a lateral blast because it refers to the tephra blowing out from the side of Mount St. Helens. So yeah, here's a before and after of Mount St. Helens. Originally, it had an elevation of 9,677 feet. You can see the conical shape it once had. And then look at how much it dropped in elevation, over 1,300 feet. It honestly looks like a whole different mountain nowadays. So much of it is gone. So here's why the volcano erupted in the first place, which then takes us into mass wasting. So Mount St. Helens is near a type of tectonic plate boundary called a subduction zone, which caused magma to build up underneath the summit of the volcano for a while. This eventually caused a cryptodome to form underneath the surface of the mountain, which is basically a temporary dome that begins to form when magma keeps building up underneath the summit area, weakening it. So while that was forming, it simultaneously caused the shifting in pressure of the mountain's structure around it, causing 10,000 earthquakes to occur between March and May of 1980. So just imagine all this pressure building up and earthquakes happening underneath the surface for 2 straight months, and then finally the pressure reached its tipping point and a magnitude 5+ earthquake occurred inside the volcano. And when that happened, that caused the cryptodome to collapse. That collapse caused a major landslide called a debris avalanche to occur. This was the largest debris avalanche ever recorded in history. It ran down the North Fork Toutle River Valley for 14 miles. The total avalanche volume was 3.3 billion cubic yards, which equals out to about 1 million Olympic-sized swimming pools. So the landslide removed the entire north flank of the mountain, or side of the mountain, which then allowed the magma that was trapped underneath to erupt. The pumice and gas material that had been spewed out of the mountain began to melt the snow caps on the mountain's exterior, which then caused avalanches called pyroclastic flows. Lahars were also formed, which are mud flows that were created from the ash and rock that erupted from the mountain. We talked about this stuff earlier in the semester, if you remember. So you have mud flows, landslides, and avalanches all coming down this mountain and into the community below, and that caused major damage. And then you have thousands of trees that got burned completely up in the lateral blast zone. The force from the explosion actually pulled multitudes of trees out from their roots as well. There was also a scorch zone that singed many trees, but didn't completely burn them up. Here's some more pictures. Looks like some burned trees and maybe a new lake that had formed. A lot of new lakes did form back then as a result. You have the pictures of the car and truck, which looks like they could have been stuck in mud flows. The last one could be the result of the landslide. So here you have people wearing gas masks to protect their lungs from the ash. So when the volcanic ash fell into the atmosphere, sulfur dioxide was released, which is highly toxic. And unfortunately, people did die from breathing that stuff into their lungs. There were 57 fatalities because of Mount St. Helens, and the majority of deaths were due to breathing in that ash. And in addition to the deaths, there were all kinds of financial setbacks, as you can imagine. $145 million was spent on repairing roads and bridges that were taken out. $4.7 billion worth of lumber was destroyed. So yeah, stuff like that. The good part about it was a lot of people began to get educated on volcanic activity, which is good. Millions of dollars has been spent on funding research projects since then. So I think that's pretty cool. So here you have 2 maps and 2 graphs. I thought it'd be cool to show what Mount St. Helens looked like before the eruption on a topographic map. So you can see the original elevation of the mountain listed there. The next map below is called a geologic hazard assessment map, which shows all the destruction zones from the eruption. So you can see the yellow section, which is the debris avalanche traveling down the river valley, for instance. You can see the pyroclastic flows in pink coming down from the mountain. The mud flows are in brown. The big light green section is the entire forest that got wiped out. The smaller dark green section is the scorch zone where the trees got singed. Stuff like that. Then you have the graphs on the right. So the graph on the top right shows the level of sulfur dioxide that was in the air from 1980 all the way to 2005. It's measured in tons per day. The levels were highest basically all throughout the 1980s and didn't see a rise until the mid-2000s when Mount St. Helens started to become active again. The last map is an old school seismogram which tracked data the day Mount St. Helens erupted. I honestly don't know what's going on in this one, but I thought it was a cool visual to see how they tracked data back then. So yeah, there's some facts about Mount St. Helens. Thank you for watching.